Now we continue to talk about negative exponents. Before we look at more examples, we're going to review the 5 formulas, 5 exponential rules we have learned before. But when we studied these formulas in this class and also in DO5 class, these exponents m and n, they are all positive. But now, since we talked about negative exponents, and these exponents m and n, they could also be negative numbers. Well, these 5 formulas still are still true. So let's review these 5 formulas first. X to the mth times x to the nth. And if it's multiplication and they have the same base, we get x to the m plus nth, because x to m is when m is positive, and when m and n are both positive, it's like multiplying m copies of x and n copies of x, and together we have m plus n copies of x. And there's what if we raise x to the mth and then raise the mth power to the nth? We have to multiply the exponents. So the first two are easily confused. And the tip I gave you in class before is, if you have those two exponents, m and n, right beside each other, we actually call it a power of power, because these two powers, you raise one power to another power, and we multiply these two powers. But in the first formula, these two powers, m and n, they're not beside each other. When we don't raise the first m to the second n, so we add them. So that's a tip to help us to memorize quickly. Now, number 3, what if in the base there is a multiplication? And we can raise each factor. So if it's multiplication between two things, we call each of them a factor, just like the factoring problems we did before. So we raise x to the nth and raise y to the nth. It's kind of like distributing the outside exponent to each one in the base. Now, the 4th formula is similar to the first, but the only difference is we're not doing multiplication, we're doing division. And when we divide two exponents, we actually subtract, we keep the base x, we subtract the exponents. So for multiplication, when we multiply exponential numbers, we keep the base, only add exponents. But if we divide, we subtract the exponents. Now, the last formula is sort of similar to the third. In the base, we have division instead of multiplication, but we can still similarly distribute the exponent to the top x and to the bottom y. So we raise the top to the nth and raise y to the nth. So these are the 5 formulas we learned before. And notice again in the previously, those m and n, they have to be positive integers, but now they can be negative, they can be 0. These formulas are still true. So now we can look at some examples using these formulas. And all right, so the continuing, the next example will be example 3. We multiply a to the second times a to the negative third times a to the negative fourth. And in previous video, we discussed the definition of a negative exponent, which means flip the positive exponent. So we first ignore the negative sign, we got a cubed, and then we flip a cubed, we got 1 over a cubed. And similarly, a to the negative fourth means 1 over a to the fourth. So one possible way we could do the problem is, for the positives, we keep it. For the negatives, we can get rid of them and try to multiply them. But this way is a little tedious, because if there's a negative exponent, we have to flip it. The negative, we have to flip it. So if you have a lot, then you have to do the flipping many times. So that's not the way I recommend. I would always try to use these 5 formulas first. And when we get an answer, and we try to get rid of negative exponents. So the tip is always use the formula first. Use these formulas first when you get a question and a problem like this. Okay, so when we look at these 5 formulas and the problem, we realize it's very similar to the first one. And in the first formula, we only have 2 of them, but it also works if there are 3 of them. So previously, the problem we did was all positive exponents, say a second times a third times a fourth. And we know that we can just keep the base a and add the exponents, 2 plus 3 plus 4 to get a to the 9th. Well, if some of them are positive, some of them negative, the formula still holds. So we're still going to add all these exponents. So we keep the base a, applying the first formula, and we're going to add exponents 2 plus negative 3, because the plus sign, the formula tells us to add. That's why we have a plus sign here. But the second formula is negative. That's why we have negative. And then plus the next exponent, which is negative 4. So we're going to get a to the 2 plus negative 3. It's negative 1 plus negative 4. That gives us negative 5 as the answer. Notice the way we're doing it is exactly the same as the way we did before. We're using the same formula, the first formula. We're adding them. But since some of them could be negative, you may think you are doing subtraction, but you're still doing addition. It's just adding negative numbers. So the idea is the same. In DO5, usually when we get it, so let me erase this here. So when we get an answer, if the exponent is negative, we would like you to eliminate the negative exponent. Usually in high-level math, especially calculus, and we may like to keep the answer in this form, a to the negative 5th. And so you could, in this class, unless the instruction says eliminate the negative exponent, you can leave your answer this way. But if they tell you, say, eliminate the negative in the exponent, so we just have to apply the definition. Temporarily ignore the negative sign, we get a to the 5th. And then the negative sign tells us to flip a to the 5th, then to the bottom, then we get 1 over a to the 5th as the answer. So both answers are acceptable. Either leave it as a to negative 5th or 1 over a to the 5th. Now the first one is called exponential form. The bottom one is called the fractional form. Okay, so let's look at the next example. So in the first example, I used the formula 1, the first formula. Now in the next example, a squared times b times c to negative 3, and we raise the whole thing to the negative 4th. And notice in the base, between a squared and b and c to negative 3, there's nothing there, which means multiplication. And it's similar to the third formula. And if there's any multiplication, if there is multiplication in the base, we can distribute the exponent. Or you can say raise each factor to that exponent. So we're going to distribute the negative 4th power to each one. I'm going to write down the step. So we raise a squared to the negative 4th. And then we raise the second factor b to the negative 4th. And then we raise c to negative 3 to the negative 4th. So in this step, I'm using the third formula. If there is multiplication in the base, we can raise the exponent, each one to the exponent on the outside. So now we're going to work on each one here. For the first one, a, we will raise a to the second, and then to raise the second to the negative 4th. And that's exactly the second formula. So for this part, we can apply the second formula. It tells us when you have 2 exponents right beside each other, power, you multiply them. So we're going to do 2 times negative 4. That gives us negative 8. And b to negative 4. There's nothing to do here, just copy them. And the third one's also the second formula because these 2 exponents right beside each other, and we can multiply them to get negative 3 times negative 4, that's a positive 12. So we got c raised to 12. And now we can keep the answer this way, but if we want to get rid of the negative exponent, and we can put a 1 underneath and try to flip the negative exponents to the bottom. So the negative sign in the exponent tells us to flip this exponent. Negative tells us to flip, but notice 12 is positive, so we don't need to flip the last one. We keep c to the 12 on the top because it's positive 12, and the other two we flip them to the bottom. We get a to the 8th and b to the 4th. All right, so this is the answer. Now, next example. Now, when we look at this example, notice that there is a division in the base. And looking at these 5 formulas, the last one has a division in the base. So first thing I'm going to do is to distribute the outside exponent, negative 4, to each one inside, on the top and on the bottom. So we're going to get y squared, put y squared on the top and x to negative 3 on the bottom. Then we're going to raise each of them to the negative 4th. Raise this to the negative 4th. And now on the top, the second power and negative 4th power, they're right beside each other. Power of power, we multiply them to get y to negative 8th. On the bottom, we multiply them. Negative 3 times negative 4, we get x to 12. And again, you can leave, we cannot leave the answer this way because this is sort of like combination of fractional form and negative exponents. We would like to either get rid of all the negative without, you can use fractional form, or you can get negatives but no fraction. So you cannot have both fraction and negative exponents. Usually that's not acceptable. So either like this answer, you can have negatives but no fractions, or you can have this answer, you can have fractions but no negatives. So we're going to choose to get rid of negative exponent. Negative 8, we flip it to the bottom, y to the 8th. And don't flip x to 12 because 12 is positive, so we leave it on the bottom. And there's nothing on the top. We're going to put the 1 there to hold that place because, you know, there's 1 times y to negative 8. Usually we don't have to write 1, but if we flip that to the bottom, we have to put that 1 back. So that's the answer. So in this example, notice we're doing division, and there's no exponent on the outside. We're just going to separate them into 2 problems to divide the one with the same base. So we can use the 4th formula. The 4th formula tells us if we divide exponents with the same base, we subtract the exponents. So for the first part, we're going to keep the base a because they both have the same base a. And then we subtract the exponents. So be very careful here. The top exponent negative 3 minus the bottom exponent positive 3. So we keep the top and keep the bottom. That first minus comes from the exponent. The second minus comes from the formula minus there. Now similarly, for the second part, we keep the same base b, and we take the top exponent negative 2 minus, going to use the red color for the minus in the formula because there's going to be another minus. But the next minus sign comes from the exponent. So you're going to get negative 2 minus negative 3. And now we use the sign numbers rules. Negative 3 minus 3, negative 6. And b, negative 2 minus negative 3, we got to do keep, change, change. So keep the first number, change, and change. So it's actually doing addition. Negative 2 plus 3, that gives us a positive 1. So the answer will be a to negative 6 times b. If we want to get rid of this negative in the exponent, we have to put a 1 underneath and flip it to the bottom to get a to the 6. And b to the first can stay on the top. And the first exponent can be omitted. So be very careful that don't do negative 2 minus 3. You have to do negative 2 minus negative 3. And 2 negatives become a positive.